Welcome to Touch Develop's informational video, ColorDrop. Using the properties of physics, we will create a sprite-oriented application to help familiarize you with the properties of the API function colors RGB. Beginning our program in the main method, our first line will be a variable, which will become our board. This capability is unlocked via Media, Create Full Board. To access our board in lines to follow, we click the variable title and then Promote to Data, creating a global. Below this declaration is a command in which we implement data board to create boundary. Leaving the parameter at 0 ensures no sprites we create will be allowed to exit the screen. Next, we specify our line with another variable, this time modifying it as a sprite set through the options data, board, and create sprite set. To remember this record with ease, we retitle it set and promote it to a global. To finalize our main method, we must make a command so that all we've created and all we plan to create in the future is visible on the screen. We do so via data, board, and then post to wall. Having completed our main, we now exit and return to the home screen. Next, we will create a new method, the method physics, which has been explained thoroughly in more basic Touch Develop videos, so it will be quickly added. For review, we begin our method with a variable that will represent the acceleration on the board so that the board's gravity may be accurately assessed. We define through senses, acceleration smooth, and then scale to 200 since we would like a gradual uniform movement. The title A then abbreviates the functionality of our acceleration. Succeeding our new variable is a command in which we employ A through data board set gravity, and then set A for both parameters, extracting the respective x and y values for each. The remainder of physics will be visibility settings, formed within two commands. We first evolve the board by taking data board and opting for the eponymous selection evolve. In our second command directly beneath, we take data board once more and then update on wall. The entire physics method can now be entered into the event game loop so that the properties are ever present and constantly being recalled. This is done within the body through a command, using options code and then selecting the method title. All of the code up until this point has been review, found within more elementary videos. It is in the final method, which we rename color, that will address the colors, opacity, and friction effects we intend to apply on the sprites. Entering the empty body of our new method, we specify our first line as a for loop. We set the loop to take 30 iterations, as we intend to create 30 sprites to append to our present sprite set, set. Within the for, we will begin with a variable entitled rect, a shortened version of rectangle, which will be the representative title of each additional sprite. Through data, board, create rectangle, we are given the opportunity to alter the given parameters, so we change the width of the sprite in pixels to that of the board via data, board, width, and then we leave the height as the mechanized input. Following this line within the for, we issue a command telling variable rect to set position. Desiring to center the rectangle horizontally, we enter data, board, width, and then divide it by 2, placing the center of each sprite at the center of the board. Again, we leave the pre-programmed y value. Expanding the script within the loop further, our next command will call forward rect once more, this time instructing it to set opacity, the parameter of which will be based on iteration. Since the degree of opacity for a sprite is set between 0 and 1, we want to use iteration count to create variation, but as a decimal. By dividing the variable I by 50, we fulfill both these requirements. The command under set opacity shadows its predecessor, this time through rect, and its option set friction, which also takes parameters between 0 and 1. 0, in terms of friction, obviously represents no restraint, while 1 indicates no permitted movement whatsoever. Having set all planned properties outside color, we will now be introduced to a rudimentary understanding of RGB. To create a blended rainbow of sprites, we will stack if-then statements to categorize our sprites by color in groups of 5. Our first if, therefore, runs if I is less than 5. If this factor is met, then the variable rectangle will react. The reaction of rect is planned within the contents following then. Therefore, if this factor is met, then variable rect will set color to colors from RGB. RGB stands for red, green, blue, and the numerical value for each represents the presence of each blended in the overall color. All three numbers are out of 255, and it is solely 255 and 0 which we will use in our code today. Our first 5 sprites to fall will be red, and red only requires the presence of red, so we input 255 for the first parameter and leave the rest, green and blue, to 0. If I was not in fact less than 5, we run another if statement, this time checking if the iteration is less than 10, ensuring to code in the first else statement to remain between 5 and 10. If it is between these numbers, we create a yellow sprite through rect, set color, colors to RGB, and then 255, 255, 0, since blue cannot be used to partake in the makeup of yellow substance. The pattern of if statements increasing by 5 and the shifting of each color category's expenditure repeats until I is less than 30. We will fast forward through these actions while indicating all important differences so that we do not duplicate the same lesson over and over. The combinations used include green, while I is less than 15, is created through solely its own dispersal, meaning 0, 255, 0. Cyan, while I is less than 20, is formed by blending full amounts of both green and blue, the second two categories. Blue, while I is less than 25, uses only itself for entry, again being in the last position. And finally pink, while I is less than 30, combines 255 of both red and blue, the edge colors. After detailing the quintets with their specific color combinations, a line must end the loop by selecting the entire if segment and then add below. This final line, a command, adds each rectangle to the set by use of data, set, add, and then the programmed parameter rect. Before running our script, we must first apply our color method by returning to main and adding a line above board, post to wall. Our last but still vital line of code will state code and then color. Now that we've added all methods to the main, we may press run and see our app in activation. Congratulations! You have now completed TouchDevelop's informational video, ColorDrop.